Hi there, welcome to my video on exponential transformations. In this section, we're going to look at what happens when we take a base or a parent equation and manipulate it by changing some numbers. So first, we're going to look at the equation y equals 2 times 3 to the x. If we go back to our last lesson, we know that this means our initial amount is 2, and our multiplicative rate of change is 3. So it's growing by a factor of 3 every time. Now, with this, I have two different equations. The next equation I have is 2 times 3 to the negative x. So the equations are still the same, but now I'm raising it to a negative exponent instead of a positive. And then the third equation is negative 2 times 3 to the x. So now instead of starting with an initial amount of 2, I'm starting with an initial amount of negative 2. And what we're going to do is we're going to look to see how changing these two numbers affects the graph. So to do that, I'm going to go to a great tool I use all the time, Desmos. So into Desmos right here, I've typed our original equation, 2 times 3 to the x. I can see right away that my initial amount is 2, because when x was 0, the y amount was 2. And I can see how it grew. Well, now let's take a look at what happens when I take this equation, but I make my exponent negative. Now, we can see that instead of being a growth equation, it's actually decaying. So it's shrinking as it goes. Notice both of the equations still have the same horizontal asymptote of 0, because if we were to zoom in, every time I zoom in on this line, even though it looks like it gets to 0, the more that I zoom in, I can see that it never actually touches 0. And the same goes in the other direction also. So even though it looks like it'll touch 0, it never actually will. So what we can see here between the blue and the red lines is they are actually mirror images of each other. So what that means is it is a reflection. And later on in this unit, we'll actually talk some more about reflections. But for now, we're going to go over here, and on my notes, I'm going to write that my transformation, if I make the x negative, so a negative exponent, reflects the line across the y-axis. And technically that means the reflection line is at x equals 0. Because technically if we go back right here, the x-axis is the point where x is equal to 0. So anytime if we leave these two equations the same, if all we do is change the exponent from a positive to a negative, that means everything just becomes a mirror image and it reflects across that line. So now let's get rid of that graph. And now let's look at the next example. Let's look at what happens when I leave my growth the same, but I change my initial amount. Now when I turn this on, I can see that instead of growing, it's decaying again, but now, since the initial amount is negative 2, it's starting here and going down. If I zoom in again over here, I'll still have a horizontal asymptote at y equals 0. This isn't going to change. And just like the other one, I notice now I have a mirror image again, but now the mirror image isn't across the y-axis, it's across the x-axis, or this line is y equals 0. So what that shows me is if all I do is change the initial amount from a positive to a negative initial amount reflects the curve across the x-axis. So our reflection line is now y equals 0. And in both of these cases, the horizontal asymptote is at y equals 0. So this is the first kind of transformation, having either a negative exponent or a negative initial amount. But now we're going to look at what happens if I take an equation, y equals 3 to the x power, and now I change it by either putting a plus or a minus after it, or I put a plus or a minus in the exponent, and it's going to do something all new again. So just like last time, we're going to go over to Desmos. And if you need time to write these down, feel free to pause the video and then come back. So if I go over to Desmos, let's clear off the last problem. Let's get rid of both of these. And now I'm going to graph the parent function of 3x. We're going to zoom in a little so we can see it better. So even though there's not a number here, technically the initial amount is 1. And if I look here, I can see it starts at 1. And then it's growing. And every time it goes up by 1, it's increasing by times 3. So if I zoomed out to 2, we would see it crosses at 2, 9. So first, let's look what happens if I take the graph and I put a plus 3 on it. Now we can see that instead of the graph starting at 0, 1, so here it started at 0, 1, 0, 1. Now it crosses up here at 0, 4. So that means that it shifted up 3 units, which makes sense because it says take your answer and add 3. So if you're thinking, well, what happens when it goes down? It goes down when we make it a minus 3. On that one, it started at 1, and now it went down 3. So now it's at 0, negative 2, because from here that's 1, 2, 3. So our first 2 rules is if you have the equation, if after it goes up some number, that means that the graph moves up that number of units. If you see it's minus a number, that means the graph moves down that number of units. And then it's also important to think about the asymptote. So let's go back and look. And on this one, normally my asymptote is at 0, but when I shifted it down 3, now I can see that my asymptote is at negative 3. On the one that went up, my asymptote is now at positive 3. So that means our asymptote becomes that new number. So if I had an equation of y equals 2x minus 10, that tells me the graph is going to shift down 10, and now my new asymptote is at y equals negative 10. Let's look at the last 2. We're still going to use our y equals 3x. Let's turn off these ones. Let's go back to our screen here. And now let's look at what happens when in the exponent I put a plus 3. Now, it's done something new. The asymptote is still here at y equals 0, but I can see that as it goes up, it actually shifted 1, 2, 3. So it actually went over 3 units to the right. And if you're guessing, well, that means the other one must go to the left, you'd be right. The other one goes over 1, 2, 3 to the right. So it's kind of backwards of what you'd think. A minus actually moves it to the right, and a plus actually moves it to the left. So if we go to look at it right here, we can say that a positive number moves it to the right, and a negative moves to, oops, I did it backwards. So a positive moves it to the left, and a negative moves it to the right. And in this case, the asymptote remains the same at y equals 0. So I hope these notes have helped you understand how equations move. If they give you an original equation and a new equation, like this, you just have to decide what direction did it move. Did it move up, down, left, or right? Or maybe it moved a combination of the two. And then you just have to remember, where do the numbers go? If it moved up or down, in our equation, y equals a times b to the x. If it moved up or down goes after the answer. And if it moved right or left, that goes in there with the exponent. Hopefully this video has helped you, and I hope you'll keep watching for the next unit.